Welcome, everyone, to the Deep Dive. This is where we focus on daily current affairs, especially for your UPSC preparation.
That's right.
Today, we're digging into some important developments from April 24th, 2025. This is part one. We'll try to pull out the really crucial insights for you.
And you might find some of these topics familiar. We may have touched on them before, so think of it as, good revision. Helps things stick.
Exactly. Solidify that understanding. We've got quite a mix today. Economy, environment, geography, a bit of culture, even some cutting-edge science and tech, all very relevant for the exam, of course.
Absolutely. It really shows how interconnected everything is, doesn't it? Vital stuff for the UTSC perspective.
Definitely. So this helps your prep. Please do give us a like and maybe subscribe for more of these deep dives.
Okay, so where are we starting today?
Right, let's kick off with the economy. The term sunrise industry came up recently. The finance minister mentioned India's aiming to boost manufacturing's GDP share quite significantly from around 12% to 23%. And these sunrise sectors are key to that.
Yeah, that's a big jump.
It is. So what exactly is a sunrise industry?
Well, the name itself is quite evocative, isn't it? A sunrise industry is essentially a sector that's pretty new or still developing. But the key is it shows huge potential for really fast growth.
Oh, high growth potential.
Exactly. You typically see lots of new companies popping up, often startups, high growth rates overall, and importantly, a lot of investment flowing in. Funding.
Right. An industry really taking off. And we've seen this before. The sources mentioned some examples, like back in the early 2000s, alternative energy was a big one.
Yes, I remember that buzz.
Then, maybe 2011, 2012, things like social media, cloud computing became the next wave. And more recently, blockchain tech, say 2013 to 2017. Now it seems like IT and clean energy are really in that sunrise phase.
Precisely. And often what fuels this rise is, technological innovation. These sectors are pushing boundaries, creating new solutions, sometimes completely shaking up older markets.
Disrupting things.
Yeah. Which leads to another crucial point, the industry life cycle. Sunrise industry doesn't stay sunrise forever, right? It matures.
No. It evolves. The material uses the compact disc industry as an example. CDs were the sunrise sector when they replaced vinyl and cassettes back in the 90s.
Oh, definitely. Big change.
But then digital media came along so fast, and suddenly CDs became a sunset industry, an industry in decline.
It's that constant cycle of innovation, disruption, maturity, and sometimes decline. Understanding this life cycle is, I think, really vital. It puts economic progress, tech shifts, and industrial policy into context.
So for UPSC aspirants.
For you, understanding this helps make sense of, economic growth strategies, why governments might support certain emerging sectors, or how they manage the decline of older ones to avoid major economic disruption.
Well,
the key takeaway, grasping what sunrise industries are is pretty crucial for understanding India's economic future, its trajectory.
Got it. Okay, let's shift gears a bit, moving from economic ambitions to environmental realities and the institutions dealing with them. The Supreme Court recently directed the National Environmental Engineering Research Institute, NEERI, to do an assessment related to glass industries near the Taj Mahal. NEERI sounds important.
Oh, it absolutely is. NEERI, or CR-NEERI, is a major player. It was set up way back in 1958 in Nagpur.
1958, wow.
Yeah, quite established. Initially, its focus was more on, water supply and sewage, but it's evolved hugely. It's now a top lab for environmental science and engineering in India.
And it's part of CSIR.
Correct. It's a constituent lab of the Council of Scientific and Industrial Research, CSIR, and it falls under the Ministry of Science and Technology.
Okay, a government research body. And its main job today?
Its core mission is R&D across, a really broad range of environmental issues, management, pollution control, sustainable development, you name it.
Right.
And it's not just Nagpur. They have zonal labs across the country. Chennai, Delhi, Hyderabad, Kolkata, Mumbai. So a national presence.
That suggests a wide scope. What kind of expertise do they cover?
A lot. Climate studies, environmental health impacts, lab testing, field testing, monitoring, evaluation, policy development, basic research, setting standards, tech development, even fuel R&D.
It really sounds like the go-to place for environmental science in India. This Supreme Court directive kind of underscores that role, doesn't it? Especially with something as sensitive as the Taj Mahal.
Exactly. NEERI's involvement in cases like this highlights its critical function in environmental governance and research. For your UPSC prep, knowing about NEERI, its mandate, its areas of work, That's really essential for environment topics. Their findings often inform regulations,
Makes sense. Okay, next up, we're looking at a market-based approach to pollution control, the Emissions Trading Scheme, or ETS.
Ah, yes.
The focus here is on the Surat ETS, which is described as quite groundbreaking. What exactly is an ETS?
Right. An ETS is, well, it's a regulatory tool, but it uses economic incentives to get pollution down. The basic idea is cap and trade.
Cap and trade. Heard that before.
So the government sets a limit, a cap, on the total amount of a pollutant that can be emitted by a group of industries.
Okay.
Then they issue permits or allowances, which represent the right to emit a certain amount. Companies get these, or sometimes buy them. And here's the key part. These permits are tradable.
So if one company cleans up its act and doesn't need all its permits.
Exactly. They can sell the leftover permits to another company that's maybe finding it harder or more expensive to reduce its own emissions.
Creates a financial incentive to pollute less.
Yeah.
Makes sense. But what's special about the Surat ETS? Why is it highlighted?
That's the really interesting bit. The Surat ETS, launched in 2019, was the world's first ETS specifically designed to control particulate air pollution.
Not just CO2.
No, not just greenhouse gases like CO2, which is what most ETS systems focus on, like the big one in the EU. This was for particulate matter, like soot and dust. It was also India's very first emissions market for any pollutant.
Wow, a global first for particulates. Which industries were targeted?
It focused on about 342 high-emitting industries in the Surat area. Many of these were in the textile sector, which often used, solid fuels like coal or heavy oils, which are big sources of particulate matter.
Okay. And who was behind setting this up?
It was a collaboration. The Gujarat Pollution Control Board, GPCB, worked with researchers from JPAL, EPIC at the University of Chicago, and Yale University. That kind of partnership between regulators and researchers is often key to designing these innovative schemes.
Interesting collaboration. Are there other successful ETS examples elsewhere?
Oh, yes. While Surat's focus on particulates is unique, ETS systems for greenhouse gases or other pollutants have been running for years in places like the EU, South Korea, New Zealand, and California in the U.S.
Seems like a promising strategy, using market forces.
Yeah.
But are there, potential downsides or challenges? Implementing something like this must be complex, right?
That's a really important point. Yes, it's definitely complex. You need very robust monitoring to know exactly how much each facility is emitting. You need strong oversight to make sure the trading is fair and prevent fraud.
Right.
And there are concerns about things like hotspots where maybe overall pollution goes down, but it gets concentrated in one area near a plant that buys lots of permits. So careful design and monitoring are crucial.
Okay.
But despite the challenges, the Surat ETS is a really significant experiment in using market-based instruments for air quality. For UPSC, understanding how ETS works, the cap and trade idea, and the specific innovation in Surat. That's key for topics on environmental regulation, pollution control, and, economic tools for environmental goals.
Got it. Let's shift now to geology and a natural event. The Poas Volcano in Costa Rica recently erupted. It's apparently a big tourist spot, too.
Yes, Poas is quite famous. It's one of Costa Rica's most active volcanoes, and being in a national park, it gets a lot of visitors.
Active. Okay. What type of volcano is it?
Geologically, it's a composite stratovolcano. That means it's built up over time by layers of, lava flows, ash, cinders, bombs, the usual volcanic stuff.
Right.
It's got quite an irregular shape, a really broad base, covers about 400 square kilometers, and reaches up to just over 2,700 meters.
That was pretty big. What about the crater?
The main crater is actually one of its most striking features. It's huge, about 1.5 kilometers wide and 300 meters deep. It's considered one of the largest active craters in the world.
Wow. It has been showing signs of activity lately.
Yes, for a while now. Since about 1989, there's been an increase in gas emissions, which has unfortunately caused acid rain, damaging plants and farms nearby.
Oh, right.
And more recently, in 2024, the crater lake started drying up. That seems to have triggered ash eruptions and even higher gas levels. There have also been some smaller explosions throwing out rocks.
So definitely an active and dynamic system, a good reminder of the power of these geological forces.
Absolutely. Events like this tie directly into UPSC geography topics, volcanism, obviously, but also natural hazards, risk assessment, and environmental impacts. Understanding the different types of volcanoes and their behavior is important.
Okay. Moving on, we have some positive news concerning the rural economy in India.
Good.
The Ministry of MSMEs announced that the turnover for Khadi and village industries, KDI, crossed Rs 1.7 lakh crore in the last financial year, 24-25. That's a substantial figure.
It really is. Shows the scale of that sector.
Can you tell us a bit more about the Khadi and Village Industries Commission, the KVIC? What does it do?
Sure. KVIC is a statutory body, meaning it was set up by an act of parliament, the KVIC Act of 1956.
Okay, established by law.
Yes. It functions under the Ministry of Micro, Small, and Medium Enterprises, MSMEs, and it's basically the main organization responsible for promoting and developing Khadi and other village industries across India.
So its role is quite broad: planning, promotion.
Exactly. Planning, promoting, organizing, and implementing development programs, specifically in rural areas. It works alongside other rural development agencies, too. And at the state level, there are state Khadi and village industries boards that actually implement the KVIC schemes on the ground.
Multi-level structure. What are the main goals KVIC is trying to achieve?
Well, it has several objectives, kind of layered. The primary one is about building strong, active rural communities.
Oh, yeah.
Then, socially, a major goal is creating employment in rural areas. Economically, it's about helping produce goods that can be sold, strengthening the rural economy, and maybe more broadly, it aims to foster self-reliance, especially among the economically weaker sections.
It's quite a comprehensive mandate. How does it actually achieve these? What are its functions?
It does a lot. Things like building up reserves of raw materials, setting up common facilities for processing or marketing, helping with sales, promoting research into better production techniques, providing financial aid and technical help, and also importantly, ensuring the quality and authenticity of Khadi and village industry products. They also run several major schemes you might have heard of, like PMEGP, the Prime Minister's Employment Generation Program.
Yes, PMEGP.
MPDA for Market Development, SFURTI for Regenerating Traditional Industries, the Honey Mission, and others focused on infrastructure and artisans.
It's clear KVIC plays a really significant role in the rural economy and, well, promoting that Gandhian ideal of self-sufficiency too, right?
Absolutely. For the UPSC syllabus, KVIC is very relevant for the Indian economy, rural development strategies, government schemes, employment generation, all those areas. Understanding its structure, aims, and schemes is definitely important.
Okay. Our next topic shifts focus again, this time to Afghanistan and cultural heritage. Thinking about the Taliban's stance on heritage sites brings the Bamiyan Buddhas to mind. Such a tragic loss.
A profound loss, yes. The Bamiyan Buddhas were truly monumental. We're talking about two enormous statues of Buddha carved directly into sandstone cliffs in the Bamiyan Valley back in the 6th century CE.
How big were they?
It's just massive. The taller one, sometimes called Salsal, was about 55 meters or 174 feet high. The other, Shamama, was around 38 meters or 115 feet.
Incredible scale for that time.
Absolutely. And artistically, they were prime examples of the Gandhara school of art. This was that fascinating blend you see in that region, Indian Buddhist themes mixed with Persian and Greco-Roman artistic style.
A real fusion of cultures.
Exactly. They showed a mix of Gupta, Sasanian, and Hellenistic influences. They really stood as markers of how Buddhism spread and flourished across Central and South Asia from the 1st to the 13th centuries. A crossroads of civilization, really.
It's still hard to comprehend their intentional destruction. Can you recap what led to that?
Well, it happened in March 2001. The Taliban had taken control of most of Afghanistan in the late 90s and were imposing a very strict extremist interpretation of Islamic law.
Right.
This included banning various forms of art and representations they deemed idolatrous or un-Islamic. In late February 2001, they formally announced their decision to destroy the Buddhas.
Despite international outcry.
Despite massive international condemnation and appeals from many countries and organizations, yes. They proceeded over about 25 days using dynamite and artillery to systematically demolish both statues. It was just a devastating act of cultural vandalism.
Such a loss.
It really was. Interestingly, even after the destruction, UNESCO declared the Bamiyan Valley a World Heritage Site in 2003, recognizing the importance of the entire cultural landscape, even with the niches empty.
And wasn't there a projection recently?
Yes, in 2021, there was a temporary event where they used 3D holographic projection to recreate the image of the larger Buddha, Salsal, in its niche. A very poignant moment, I think.
Definitely. The Bamiyan Buddha's story is just a stark reminder of how vulnerable cultural heritage can be.
Absolutely. And how important preservation efforts are. For UPSC, this topic touches on ancient history, art, and culture, especially Gandhara Art International Relations, UNESCO's role, and the broader issues of cultural heritage protection and, sadly, destruction in conflict zones.
Okay, let's move to climate change now, specifically a phenomenon called Arctic Amplification.
Right, a very critical issue.
The 2024 European State of the Climate Report came out, noting Europe is warming almost twice as fast as the global average. And this is tied to what's happening in the Arctic. So what is Arctic amplification?
Arctic amplification basically means that the temperature changes happening in the Arctic are much stronger, much more intense than the average temperature change across the whole planet.
More intense warming there.
Yes. It's a form of what's called polar amplification, faster warming at the poles, but it's particularly pronounced in the north, in the Arctic. The fundamental reason is changes in the Earth's energy balance, mainly due to the buildup of greenhouse gases trapping more heat.
But why is it so much faster in the Arctic? What makes that region different?
There are several factors, and they kind of feed off each other. Probably the most well-known is the ice albedo feedback.
Ice albedo.
Yeah.
That's about reflectivity. Right.
Exactly. Ice and snow are bright white, so they reflect a lot of sunlight back into space. But as the Arctic warms and the ice melts, you expose darker surfaces, the ocean water, or the land underneath.
And dark surfaces absorb more heat.
Precisely. So less reflection, more absorption, which leads to more warming, which melts more ice. It's a positive feedback loop, amplifying the initial warming.
Okay, that makes sense. Are there other factors too?
Yes, things like changes in how heat is transported by the ocean and atmosphere towards the pole, changes in cloud cover, and what's called the lapse rate feedback, which relates to how temperature changes with altitude in the polar atmosphere. It's complex, but the ice albedo feedback is a major one.
And the recent report had some stark findings.
It did. It confirmed the Arctic is warming maybe 3 to 4 times faster than the global average. Globally, we're at about 1.3 degrees Celsius warming above pre-industrial levels, and the report noted we actually crossed the 1.5 degree threshold temporarily in 2024 for the first time.
Worrying milestone.
Very. And Europe itself has warmed by about 2.4 degrees. This accelerated warming, especially linked to the Arctic changes, is driving more extreme weather events, heat waves, intense rainfall, flooding across the globe, and certainly in Europe.
The report mentioned regional differences in Europe, too.
Yeah, it noted contrasts like Eastern Europe being warmer and sunnier, while Western Europe was cloudier and wetter. Southeastern Europe apparently had its longest ever heat wave. So the impacts aren't uniform, but the overall trend is clear.
It really drives home how interconnected the climate system is and how changes in the Arctic have ripple effects everywhere.
Absolutely. Arctic amplification isn't just a remote polar issue. It affects weather patterns worldwide. For UPSC, understanding this phenomenon, its causes like the ice albedo feedback and its consequences is crucial for climate change, environmental science, and geography topics.
Right. Okay, our next topic sounds like something out of science fiction almost. NASA scientists are proposing using something called a quantum gravity gradiometer, or QGG.
Ah, yes, this is fascinating stuff.
And they want to use it to measure changes in Earth's mass distribution linked to climate change. That sounds incredibly precise. What is a QGG?
It is indeed about achieving extraordinary precision. A QGG is a proposed type of instrument, potentially for satellites, designed to detect tiny, tiny variations in Earth's gravitational pull.
How does it work? It involves quantum mechanics.
Deeply. The basic idea is to use atoms' specific types cooled down to incredibly low temperatures, near absolute zero, in a vacuum. At these temperatures, atoms stop behaving like tiny balls and start exhibiting wave-like properties, as quantum mechanics predicts.
Okay, wave-like atoms.
Then they use lasers to manipulate these ultra-cold atoms very precisely. As these atom waves move under the influence of gravity, their quantum state changes slightly. It undergoes what's called a phase shift.
And that shift tells you about gravity.
Exactly. The amount of phase shift is directly related to the gravitational force they experience. Because they can measure these phase shifts with incredible accuracy, a QGG can detect differences in gravitational acceleration as small as 10 to the power of minus 15 meters per second squared over just a meter's distance.
That sensitivity is hard to even grasp. What could you measure with that? It's like having super sensitive scales in space.
Kind of, yeah. Or think of the atoms like incredibly sensitive floating balloons, as you suggested earlier. The tiniest gravitational tug makes them wobble, and the QGG measures that wobble. With this sensitivity, you could potentially estimate the total mass of huge features like the Himalayas more accurately.
Wow.
More relevant for climate change, you could monitor the movement of water, groundwater, and aquifers, melting ice sheets in Greenland and Antarctica, even shifts in rock and soil, all from orbit, by detecting the tiny gravitational changes these mass shifts cause.
Because gravity depends on mass nearby, right? Stronger near mountains, weaker over less dense areas.
Precisely. Gravity isn't uniform. A gravity gradiometer generally measures how gravity changes from point A to point B. Current non-quantum versions are already used in things like oil and gas exploration, looking for variations caused by underground structures.
But the quantum version is much more sensitive.
Orders of magnitude more sensitive, potentially. This leap in precision could be revolutionary for mapping underground features, finding hidden cavities, tunnels, mineral deposits. Think geology, archaeology, even defense applications.
So it works by tracking these ultra-cold atoms behaving as quantum waves and spotting tiny gravity-induced shifts.
That's the essence of it. It's using the weirdness of quantum mechanics to build an incredibly powerful sensor for gravity.
Amazing. It really feels like quantum tech is moving from theory into practical, world-changing applications.
It certainly seems that way. This kind of technology could give us unprecedented insights into Earth's systems and how they're changing. For UPSC, this is prime science and tech territory space technology, quantum mechanics applications, environmental monitoring, resource management. It connects a lot of dots.
Definitely one to watch.
Yeah.
Okay, let's bring it back down to Earth, literally, with some extreme weather. There's recent torrential rain and hail in the Ramban district of Jammu and Kashmir.
Yes, I saw reports of that.
The IMD noted rainfall was way above normal, like 16.9 millimeters when the normal is 2.5 millimeters. That's a 575% increase. Sounds like it could have been a cloudburst.
That kind of intensity certainly suggests it. A cloudburst is technically defined as extremely heavy rainfall localized in area. The usual threshold is 10 centimeters. That's about 4 inches of rain falling in just 1 hour over an area of maybe 10 by 10 kilometers.
Or even faster.
Or sometimes defined as 5 centimeters in half an hour over that same sort of area. It's just a massive amount of water coming down very quickly in one spot.
And they happen more often in mountains, right? Why is that?
Yes, they are much more common in hilly or mountainous terrain. It's mainly due to something called orographic lift.
Orographic lift.
That's when warm, moist air moving horizontally encounters a mountain barrier and is forced to rise up the slope. As the air rises, it expands and cools, which causes the moisture in it to condense into clouds and eventually rain.
Okay, standard rain formation, what makes it a cloudburst?
In a cloudburst scenario, you get conditions where a large amount of this moist air accumulates, maybe held up by strong updrafts, without releasing the rain gradually. Then suddenly, something triggers a massive, rapid release of all that stored water. It just dumps it all at once.
Like a water balloon bursting in the sky.
A pretty good analogy, actually. And because they form quickly and are so localized, they're very hard to predict accurately. They can completely overwhelm streams and drainage systems, leading to
Flash floods and landslides.
Exactly. Those are the major hazards associated with cloudbursts in mountains. A flash flood is just that, a very sudden, rapid rise in water levels, often in streams or low-lying areas, because the ground can't absorb the intense rain fast enough and the runoff is immediate.
More dangerous than regular river floods.
Often, yes, because they happen with so little warning. Landslides are the other big risk. All that intense rain saturates the soil and rock on steep slopes,
Making it heavier and unstable.
Right. It increases the weight, reduces the friction holding the slope together, and can trigger a sudden failure, rock, debris, mud sliding downhill.
And the consequences are devastating.
They can be. Direct destruction, blocking roads, damming rivers, which can then cause flooding upstream when the dam eventually breaks. It's a cascade of hazards.
So these events in places like J&K highlight the vulnerability of mountain regions to extreme weather.
Definitely. It underscores the need for better forecasting, warning systems, and disaster preparedness in these areas. For UPSC, this connects geography, meteorological phenomena, mountain environments with disaster management, and environmental impacts.
Okay, our final topic for this session takes us to southern Africa, specifically Botswana. We're talking about the Jwaneng Diamond Mine.
Ah, Jwaneng, the Prince of Mines.
That's its nickname. It's considered the richest diamond mine in the world by value, apparently worth maybe €1 billion.
That figure sounds plausible, yes. It is widely regarded as the world's richest diamond mine in terms of the value of the diamonds it produces. It's located in southern Botswana, kind of on the edge of the Kalahari Desert, about 170 kilometers southwest of Gaborone, the capital.
And who runs it?
It's operated by a company called Botswana. This is a very important joint venture, a 50-50 partnership between the global diamond company De Beers and the government of Botswana itself.
That partnership must be crucial for Botswana's economy.
Hugely. The name Jwaneng actually means a place of gems in the local Setswana language. Very appropriate.
How did they find it? Is it a specific geological formation?
Yes, the diamonds are found in what are called kimberlite pipes. These are ancient volcanic structures, essentially conduits that brought magma and diamonds formed deep within the earth up towards the surface millions of years ago. The Jwaneng pipes were discovered by De Beers geologists back in the 1970s.
And it's been operating for a long time.
Since 1982. And it's been incredibly productive. We're talking hundreds of millions of carats recovered over the years from its 3 main kimberlite pipes. In 2023 alone, it produced something like 13.3 million carats.
Just staggering numbers. The total value must be immense.
Estimates suggest the total revenue generated since it opened has crossed 96 billion US dollars. It's a cornerstone of Botswana's economy.
How do they mine it? Is it technologically advanced?
Very much so. It's a large open pit mine using huge drills, shovels, and trucks. The ore is then processed using state-of-the-art technology, including X-ray sorting and lasers, to separate the diamonds from the waste rock efficiently.
And any focus on environmental aspects?
Yes, apparently Jwaneng was the first mine in Botswana to get ISO 14001 certification, which is an international standard for environmental management systems. So they do put emphasis on that.
So a huge operation, economically vital for Botswana using advanced tech, seems relevant for geography and economy topics.
Definitely. It fits right into UPSC topics on mineral resources, economic geography, specifically relating to Africa, international trade in commodities like diamonds, and the economic impact of mining.
Well, that brings us to the end of our deep dive for today. We've covered quite a spectrum, haven't we?
We certainly have.
From Sunrise Industries and NEERI's role in environmental protection,
To the Surat ETS, the Poas Volcano's activity.
KVIC's impact on rural India, the history of the Bamiyan Buddhas,
Arctic Amplification, the potential of quantum gravity gradiometers,
the dangers of cloudburst, and finally, the immense wealth of the Jwaneng mine.
a real tour of current affairs relevant to the syllabus.
We really hope this closer look at these key developments from April 24th, Part 1, has been useful for your UPSC preparation, giving you a clearer understanding.
Remember, consistently engaging with these kinds of analyses helps build that broad knowledge base and the ability to connect different issues.
Absolutely. Take some time to reflect on these topics, maybe do a bit more reading on the ones that caught your eye. And of course, if you found this helpful, please do hit that like button and subscribe for more sessions like this, tailored for your UPSC journey.
Indeed.
And maybe a final thought to leave you with. As we see these incredible advances in technology, like the QGG, alongside market tools like ETS, how effectively do you think we can harness innovation to tackle the really big challenges like climate change and sustainable development going forward? Something to ponder.